Okay, so in this video we're going to talk about how to find the area of a segment. So I think the trickiest part is drawing them out. So I have sent you already the pictures and the drawings of all these problems because I think that's part of the problem is they don't give you those pictures. So let's walk through one and hopefully this will help figure some stuff out. So you'll notice I already have the picture drawn and I want to find the area of the segment. So I think it's kind of a little bit misleading as to what a segment really means. So because a line segment, what they do is you draw in this line, which is your line segment, okay, which is a chord on the circle. But they really want you to find like this shaded region here. So this is what we're trying to find. So if you'll notice, I wrote a formula up here that we're going to use, and this is kind of like the model for all of the problems that are like this. So in order to find the area of the segment, we're going to look here and we're going to say, if I look at like a piece of pie or a piece of pizza, this whole part right here, if I could find the area of that and take away the area of this triangle, then I would be left over with this like section of crust, if you will. So let's go ahead and figure this out. So we'll start with the area of the sector. So let me just switch back to my pen here and get a different color that's not bright pink. So we know that the area of a sector is equal to the degrees you have over 360 times, and remember the area of a sector is like part of the area of a circle. So we're going to take a piece of the area, which is my degrees over 360, and then we're going to multiply it by pi r squared because that's the area of my circle. So I'm looking at this and they're telling me that I already know my degrees is 120 divided by 360 times pi, and then I have to fill in my r squared. So this is the part where it gets a little bit tricky. All right, so what is my radius? This is going to be my radius of the circle right here. So I have to figure out this value. So you'll notice that they tell you here, whoops, oh boy. So right here, this whole line segment is 8 times the square root of 3. If I draw and cut this in half, that means I'm cutting my initial segment in half, making this side 4 times the square root of 3 and this side 4 times the square root of 3. Well, you can't see that very good. Let me choose a different color here. What about this? 4 times, there we go, times the square root of 3, and this one is 4 times the square root of 3. Okay, so now the other thing that I know is that when I cut this angle in half, this is a bisector, which bisects my angle, which makes each one of these angles 60, and it cuts my segment in half. So now I'm looking and I say, oh, now I have a 30, 60, 90 triangle, so we're going to use the 30, 60, 90 shortcut, which I'm going to do up here. If you remember, the 30, 60, 90 shortcut says across from my 90 value is 2 times A. Across from my 30 degrees is going to be A, and across from my 60 degrees is going to be A times the square root of 3. I happen to write my picture like this because it is in the same orientation. If you look at, we'll say we're going to be using this triangle. It's in the same orientation as this triangle where I have my 60 degrees on the top, my 90 degrees on the bottom, and on the left I have my 30 degrees. So what I want to do is I want to match up my sides. So when I match up my sides, I get the following. I get A times the square root of 3 matches with 4 times the square root of 3. Oops, sorry. A times the square root of 3 matches with 4 times the square root of 3. So now, if you'll notice, once I find my A value, I can find all the sides of my triangle. So if A times the square root of 3 is equal to 4 times the square root of 3, and I divide both sides by the square root of 3, I get that my A value is equal to 4, which is really super helpful because that means that this side is now going to be 4, which would be here, and this side is going to be 2 times 4, which is 8, which is going to be here. So that means that my radius is actually 8. So now I have the information for my area of my sector. So now I need next to find the area of my triangle. We know that the area of a triangle is 1/2 base times height. Okay, so in this big triangle, we're looking here at this triangle here, this outline of the blue triangle. Okay, my base is the whole thing here to here. So I do 1/2, my base is 8 times the square root of 3 times my height. My height is how tall my triangle is, which is this value right here, which is 4, because we just figured that out. So now I'm going to plug all this into my formula, which is up here. So the area of my segment is equal to the area of my sector, which is 120 divided by 360 times pi r squared minus the area of my triangle, which is 1/2 times base times, oh shoot, I'm running out of space. Let me try that again. Minus 1/2 times base times height. Okay, so now I can just figure this out. If I reduce this as a fraction, 120 divided by 360 is the same as 1/3 times pi times 64 is 8 squared, minus 1/2 of 8 is 4, and 4 times 4 is 16. 16 times the square root of 3. Really, you can leave your answer like this, or you can plug it in on a calculator, but I'm perfectly fine with you leaving your answer in this form. So my answer is, let me fix this, it looks a little bit like an 8. 1/3 pi times 64 minus 16 times the square root of 3. If you have any other questions, please let me know, but I think that gives you a good idea of how this works and how the